Okay, well, again, welcome everybody. Um, this is the first webinar in a long series of webinars that were put together. Essentially what we've done is we've taken our live workshop and put it all into small little pieces. So this is the introduction. It's kind of the overview of the concepts of what we're going to be talking about and some of the key major pieces of what the webinars will be unfolding, I guess, as you get towards go through it. And we're taking this idea of a life-focused approach to agriculture. There's a lot of names for it. Regenerative agriculture, sustainable agriculture, biological approach, all these different things. And the emphasis that we want to make with this idea of a life-focused approach is that if we focus on the living aspects of the soil and the plants and the people and the animals, then it allows us to build basically a farm or whatever you're doing, whether it's a backyard garden or 10,000 acres of pasture land in Montana, which I know there's both of those present. Or a landscape professional, whatever it is that you're doing, managing the land. We say agriculture, but we really mean anything that has to do with the soil and plants growing in it, managed by humans. So we want this to be the life-focused approach. We'll go into a lot more detail on what that means, obviously, over the course of the next 20 weeks or so, of what that really means, what that looks like in the different aspects of it. And hopefully by the end of it, we'll put it all together in such a way that you'll be able to manage your own approach, and you have your own ideas on how you will implement these things in your own operations. So also a little bit about me. I know most of you know me. Certainly a lot of you have been customers for years. Some of you may be new to Earth for it, but I started working with soil microbiology back in 2003. Those of you who know my story, it's pretty simple. I was hired by the lab to work on the computers and to do database programming. And I came in and basically fixed the system. My brother and I rebuilt the database system that managed all of the information that the lab was generating so that we could put out reports automatically. At that moment, I realized for myself personally that I was much more interested in what the lab was doing and its impact on the world, helping people manage their soils, looking at the life in the soil, doing all this science. So I switched from silicon to carbon and started learning, and basically was thrown into the fire. For those of you who know Dr. Ingham, Dr. Elaine Ingham was my mentor, and this is her original laboratory. I bought her out in 2010, and the way she trained me was she sent me to all the places in the world that she didn't want to go. So I went to Nicaragua, I went to Guatemala, I went to Suriname, I went to Ukraine. My first public talk was, she sent me to an international conference on composting in Spain, and I'd not even been doing this for a year, and I'm speaking in front of all these scientists and everything. It was really fun. It's really great. So just doing it, visiting all these countries, working with all these different farmers, all these different crops. I was surprised recently with a new crop, and now I can't even remember what it was. The one that comes to mind, the most recent one, is a couple years ago, haskap berries. I'd never heard of haskap berries, but once I figured out they were a relative of the blueberry, it was pretty easy to work with. So, but worked with just about every crop. I also create products, Soil Provide, Soil Revive. We'll talk about those kind of things. Also the Dirt Simple line of compost tea brewers and bags and all these different things that we make available, the tools to help you do this. And we're just trying to focus our efforts on fixing soil and helping people just implement this life approach to managing their agricultural and horticultural systems. So that's just a little bit about me. I going to turn off the webcam now and just go through the presentation so you don't have to look at my face. Makes me feel better. Anyways, I'll turn it back on when we get to the end. So I'll see you on the other side. So this is what we're trying to avoid. You know, I am not much of a fear monger. I do not like to use scare tactics to get people to do things. But there is a problem with our soils. They're degrading. Some of it's through climate, some of it is through man-made practices, but we've been through this before. Almost 100 years ago, the soils in America literally blew away, and that was due to soil degradation. There's been a lot of things put into place to help prevent that. The Natural Resource Conservation Service, Soil Water Conservation Districts, the USDA, even the EPA and other organizations and factors got involved to try and minimize and prevent this from happening again. But if we look at the global situation, the soil degradation, whether it's a small amount or severe, is still pretty bad. We've managed to keep the soils from blowing away too much, and we've managed to kind of minimize erosion a little bit, but there's other factors in degraded soils. When we're trying to grow a crop, if you have to fertilize, if you have to spray for weeds, if you have to till the ground just to get the plants to grow, then that is an indication that you probably have a degraded soil. And usually that degradation from our perspective has to do with the life. If the life is working, we can reverse soil degradation. It takes a lot of effort, and sometimes people don't even realize that they have degraded soils. This map, the Global Assessment of Human-Induced Soil Degradation, is available online. It'll be part of the handouts and links to information. You can go and look at this map in real time and zoom in to your area. The it's a really cool map because it's all GIS controlled, and you can go in and look at these different areas. I just wanted to put up the global. You can see this dark brown is heavily or severely degraded, and all you have to do is look at human agriculture and then just follow the trail of the brown spots. Some of this is naturally induced, but again, this map is specifically human-induced soil degradation. So this takes out factors of natural. This is just human activity. So, and some of the things that cause this, there are many factors, of course, but when it comes to the human component, one of the main components is chronic overtilling of the soil. And I like to be specific about this because a lot of people are adopting no-till practices, which is fine if that is the right thing for you to be doing. Sometimes conservation tilling is a better choice, and there is a big difference between chronic overtilling and cultivation. And whether you're deep ripping or disking, harrowing, there's all kinds of different ways of working the soil, and there's no one right way to approach this problem. Every farm is going to have its own unique set of challenges and needs but the bottom line is we want to minimize disturbance so that the life in the soil can be successful. Every time you till the soil, it creates a disruption. That disruption has a negative impact on the microbiology in the soil. If we can minimize that and allow those microbes to recover, then we can have a functioning balanced system. Chronic overtilling just prevents it from ever having a chance to recover. Another aspect of kind of modern agricultural processes, of course, is the chemical usage. And I don't have any problem with using chemistry as part of a program as long as it's a life first program. Then when you need a fertilizer, you use a fertilizer. If you have a plague of something, you might need to spray a fungicide. We work with vineyards who, if they don't manage bunch rot before it happens, by the time they see a symptom, it's too late and they lose their crop. So we're not advocating the elimination of chemicals. We're advocating the judicious use and also looking at alternatives to synthetic fertilizers, salt-based fertilizers, and any of the chemicals that are designed to kill stuff, herbicides, fungicides, nematicides, all those pesticides, use them judiciously and put them in the proper perspective. And again, these are IPM practices, these are sustainable organic practices or conventional. The idea though is to use those products and those chemicals in such a way that it minimizes the disturbance to the overall life balance so that we can have a healthy, productive farm. A lot of times the chemicals that we're using are treating symptoms of degraded soils. And if we fix those degraded soils and repair the biology that manages that, then a lot of these chemicals are no longer necessary or their use is severely diminished. So that's just kind of an overview of that. And there are other factors, of course, there's environmental factors, there's, conditional logistics of how to implement these things. That's the hard part. And that's, by the end of this class, we'll hopefully have you on a path that it help you achieve those goals, whatever they may be on your farm, to say, if these things are causing me degraded soil and reducing my productivity, how do I get rid of these? How do I change? And maybe through this process, we'll actually get you there. Okay, so enough of the problem. Let's look at some solutions here. So, Earth, little blue dot, this is the place we call home. Our perspective is that the Earth supports life, and our activities will determine whether or not life on Earth will succeed or not. Human beings have a tremendous impact on all of that. So whether you believe in human-induced climate change and human-induced, loss of species, things like that, that doesn't matter whether you believe it or not, because things are changing and we have an impact. And if we believe that and work with that, then we can start making a difference. And that's really all we're saying, is that we want to be creating a situation where we are preserving the environment while still being productive. So an example of that, just real quickly, this is corn in Ileton, California. This is silage corn. There's a lot of details to this story, but the bottom line is these guys took a swamp, drained a swamp, put some biology into it, planted their corn, didn't spray for weeds, didn't spray for insects, didn't fertilize, and just let the system go. And they got this corn, it's a beautiful stand of corn. Their neighbor, literally across the street, grew the same kind of corn in almost the same kind of conditions, although they didn't drain a swamp. I think the swamp is why it's still so green. So there's a lot of water. But these guys put down fertilizer, a lot of fertilizer. They sprayed for insects, they sprayed for silkworm, and they sprayed for fireworm. They sprayed herbicide for weeds. And the bottom line is, and you can see right there, same crop yield. They both got 5 tons per acre, but the biological side was half the cost, approximately. You know, and and that included the drying fees. So if you know anything about silage corn, it needs to be dry like this. This is the expectation. If the drier it is when you harvest, the more money you get um, per unit because you don't have to pay for drying fees. These guys' corn was so wet they had to pay an extra $100 just to get it dried down. So the point is that you know it is possible, and this is one season. This is not 5, 10, 15 years down the road. This is just one season of committing to not spraying, putting out chemicals. The other thing too that they didn't do, they tilled this field once so that they could plant. These guys, we don't even know how many times they ran over this field before planting, and then even after planting, they did some cultivation as well as spraying the herbicide. So, some of these fields, get tilled 2 or 3 times a year. Um, it's just a mess. It was a powdery mess, you know. So, anyways, it's just an example of what's possible. When we walked out into this field, every single one of these plants had a fireworm, and they'd sprayed for it. Almost every ear had a silkworm. When we walked out into our field, into the biological field, it took us about a half an hour before we finally found a silkworm. And then we got so excited because it was a big fat silkworm, but it was also on a big fat ear of corn. I mean, it was beautiful. We didn't find any fireworms, and they sprayed no insecticides. So, anyways, that's that story, just to keep things moving. And again, if you have questions, I recommend just jot them down or put them in the chat, and we'll try and get to them. We'll get to those at the end. I'm sure there'll be questions about this one. Okay, so here's another big concept about how we approach what we're doing. Here at Earth Fort, we're looking at the soil microbiology, at the life in the soil. That's our specialization. And we help people get that soil balanced and functioning again from a biological perspective. But we are not agronomists. We are not pathologists. We are not nematologists necessarily. We're not horticulturalists. We don't know anything about plant nutrition or genetics. We're just looking at the soil microbiology and helping you get that. So one of the things that we strongly encourage as part of this whole process is that this is an integrative, collaborative approach. Sometimes you're going to need a specialist that is not us or not me specifically. And so make sure to have friends that know these things. If you get some weird plant disease, figure out what it is, and then, hopefully the principle is to find a life first way to deal with that problem. And if all else fails, then, then kill it. That's fine. But make sure that it's an informed decision. Always ask the appropriate specialists. A lot of these specialists may or may not know anything about a life first approach or what you're trying to do with the biology of the soil, but they know what they know, and always have that information available to you. So I strongly encourage that. So this is about integration and having good people available to call upon. All right, next. All right, so again, these are the big concepts going through all of this. You know, one of the things that we're trying to do is we're trying to understand how nature works and why nature does what it does. If you walk out into a forest, and those of you who've worked with me, you've heard this 1,000 times, you've heard it from other people too. Who fertilizes the forest? Who fertilizes the prairie? Who is fertilizing vast grasslands, tropical forest systems, temperate forest systems, and some of the best biomass production in the world is coming out of these systems. And nobody's fertilizing, nobody's rotating crops, nobody's irrigating. There's process. There's a natural process that feeds the plants. A lot of it has to do with organic matter falling to the ground, getting consumed and broken up by the biology, and then also they're eating and pulling the mineral component out of the soil and bringing it to the plant. There is no reason that we cannot emulate these kind of processes and this kind of ecological system in our agriculture. Just there's no reason not to, other than the fact that modern agricultural practices have disrupted this process to a point where it no longer functions, hence the degraded soil. So this is a concept, it's the soil food web. It's the idea that, there's a cycle, it starts with the sun. All energy on this planet comes from the sun. We're solar powered. Even our oil is basically solar energy. Um, all this energy from the sun comes into the onto Earth. Plants, and this is a simplified approach because there's a lot more. You can go into a lot different weird tangents, but essentially, plants absorb sunlight energy through photosynthesis, pull CO2 out of the atmosphere, and create food. A lot of it helps the plant grow directly, but a lot of it gets pumped down into the root system in the form of root exudates, different chemicals, enzymes going down into the root system. Some of that is to help with the chemical processes of taking up nutrients from the soil. It also helps with pulling water and moisture out of the soil. But there's also a component that's feeding the microbes that live in the soil. So we have bacteria and fungi, we have nematodes, protozoa, all these different organisms living in the root system that eat and consume and live in that root of that plant. And through the natural process of eat and be eaten, we create a food resource that helps feed the plants and ultimately also feeds the animals, the birds, other higher insects, and us. So it's a very elegant system. It gets very complex very fast, but we can simplify it to a point where we can utilize it in a practical way so that we can understand, okay, what's going on down there in a way that we can manage it and understand it so that we can maybe do some things to help it out. The other part of it all is this idea of succession. And of course, Kathy is going to be doing several sessions on succession, talking about the history of soil science, the history of plant ecology and ecology in general, looking at all of the different aspects of succession. But essentially, the point of succession is very simply plants will grow in a climate that they're evolved to grow in. So the climate dictates what kind of plants will grow there. And then the conditions in the soil will determine how well they do. And from bare rock to trees, there's a progression, an arc of plant types. And the soil condition specifically has to do with the microbial balance. You can have sand, you can have silt, you can have clay, and in any combination, but grass will grow where grass will grow, no matter what those soil properties are. Now there's certain conditions obviously in the soil where nothing will grow if it's truly anaerobic or so compacted, but in general terms, grass will grow if the climate will support it and the biology is there to support it. If the biology is not there, then we have to force it to grow. And that's modern agriculture, forcing it to grow when maybe it shouldn't be. And because of that, we're fighting plants that are suited for the conditions, weeds, while we're trying to grow our grasses. Or even worse, what if we're trying to grow woody perennials in a system that's really suited for annual plants, you know. So the succession idea is very important, and it's kind of the key, uh, the core concept of everything that we do is this life fits within a niche, and we want to make sure that we're doing our part to make sure that that niche is working. And that's where the testing comes in. So we will talk about, I'll break down all of the various components, the bacteria, fungi, protozoa, nematodes. We'll break down the reports as well. So everything we're talking about, you know, whether it's biology or even the chemistry, you know, we provide that testing, we can do that testing. We want to be able to see it. If you can measure it, you can manage it. Nice little mantra from the industrial age, had more to do with human beings, but it works for biology as well. If we know what our balance is and what that biology is, then we know what that plant needs, then we can put those two things together and it will help us make decisions. So using the microscope to measure these things is very important. And these are snapshots, you know, we'll go into a lot of detail. I basically got 5 or 6 sessions just around plant succession, so different groups of plants in the different successional categories, and we'll go into a lot of details on bacteria, fungi, protozoa, nematodes, and also soil nutrients and how those are interrelated. And of course, there's a little test kit. You can always send things in. Most people send it in direct. I think you can buy these on Amazon. They're cute. They make great gifts too. But you know, and then another aspect of what we'll be doing is looking at the tools for building soil. We put this picture up. This is Provide and Revive. These are the two products that I created. But there are a lot of other products and a lot of other practices, as well as, you know, change in management style. So we'll talk about till or no till, um, you know, how to cultivate, or maybe not how to cultivate, but cultivation and where it plays in, composting, compost teas, compost extracts. We'll cover all of the, you know, commercially available products like Provide and Revive, things that you can make at home. I'll touch on Korean natural farming, indigenous microorganisms, different, all kinds of different soil amendments. So we'll go through um, a few different types of amendments and fertilizers. You know, people are interested in how to improve their fungi without necessarily buying a product like Revive to do it. You know, we'll talk about things like that and how to mulch, you know. And the key is that, you know, a lot of the times the problem with do-it-yourself approach versus commercially available products is really comes down to logistics. What is reasonable for you know, the logistics of the size of the operation. If you've got 1,000 acres of almonds, are you really going to be able to make enough compost tea, for example, to treat those almonds? And are you making a good enough tea for that job? Whereas, you know, treating 100 acres of hay is a whole different level of operation. So, you know, those are the kind of things that we'll touch on as well. And, you know, we're here to try and help. The whole point of this is at the end, give you the tools and ideas that you need to decide how best to implement these practices on your own farm. So just another real quick before we wrap things up and go into the Q&A. This is the rose garden. Avery Park Rose Garden here in Corvallis. It's like walking distance from my office. We've been working with them for 6 or 7 years now, and they came to us with the simple question: can we stop spraying fungicides and not lose all of our roses? Right? They sprayed fungicide every other week during the growing season to keep down powdery mildew, black spot, rust, and a few other things. They had a couple different types of mildew. So we went in and tested the soil, looked at what was going on, modified some of their practices. They were putting in too much mulch and they were overwatering, so we reduced that. They were over fertilizing, and of course they were putting chemical out. So we changed a bunch of things, started putting on Provide and Revive as a biological food and inoculum, and then basically they never looked back. There's still disease in this garden, but it's nominal. It's a few susceptible varieties at certain times of the year might show some powdery mildew or black spot, but overall the whole garden is really healthy. And this is an acre of roses. There are hundreds and hundreds of plants in here in this acre. Like I said, they never look back. They've never had any real problems. In fact, they didn't even have to fertilize for 3 years. And then she started doing a really light organic fertility program because there was so much uh, built up in the soil that the biology just worked through that and was enough to feed the plants for quite a while. So the biggest for me though was the life approach. When we first started working with them, I went into a rose garden in full bloom in the summer and I couldn't smell a rose and I couldn't find any insects. There was just hardly. I think looking around after 20 minutes, we finally found a bee that was struggling. Um, they started doing the products. They stopped spraying the fungicides. We went back a month later. I could smell the roses from the parking lot, and we stopped counting insects after a couple minutes. We found wasps and bees and spiders and aphids and lacewings and ladybugs, and just this huge amount of life had returned to the garden. So for me, that was a real telling instance where, oh, yeah, this is really important that we do these kind of things. Plus, it's a safer place for kids and pets and people to be because they're not spraying those chemicals. So, anyways, if you're ever in Corvallis, during the summer, you can come and visit it. If you come in the winter, it'll just be a bunch of sticks because they prune it pretty heavily. So, come in the summertime. All right. Now, I'm just going to wrap up real quick because I think I'm pushing into the Q&A. I don't want to do that, but the whole point is this is a cycle of life. The biology working with the chemistry is what feeds the plants. If we can get the life working, all of the other aspects will start to fall into place. And it's not that you stop fertilizing, it's not that you put away some of these chemicals, it's not that you put away everything that you've learned. It's learning to add this new component, this new understanding, this new perspective into your operation. And ultimately, what we're looking for is a more efficient and a healthier overall farm, or backyard garden or whatever it is that you're doing. That is the goal. It's not to, and ultimately, hopefully, maybe we'll save a few acres from running into the ocean unnecessarily or prevent chemicals from getting into our waterways. Those are side benefits that come later. But really, it's about efficiency, productivity, and restoring these soils to a point where they can support your crops. So now there's additional reading, and this list is going to be in the handouts as well. Soil microbiology, ecology, and biochemistry is a really heady, technical, scientific journal-based approach to looking at the life in the soil and these processes. There's 2 whole chapters dedicated just to the nitrogen cycle, plus all of the different aspects. It's very much modern science approach, so everything is broken down into little bits. It takes some effort to read through it and start connecting the dots. I find it invaluable because it's so rich in information. It's an incredible resource. Life in the Soil by James Nardi is a little more accessible. I think it's a nice read, and James is an excellent artist. So throughout the book is all these beautiful hand-drawn pencil drawings of different organisms within the soil. So it's a really nice book, and it's more of a walk through a naturalist perspective on the soil and the life in the soil. And then, of course, the Soil Biology Primer through the USDA, available for sale online, and I think we have a link to get it for free. You can read it online. There's a digital version of it. So I did manage to run a little over. I apologize for that. But with that, thank you very much. I will be happy to open it up to questions, assuming that we can actually do that. So I don't know, we'll find out. Can we?
Matt, would you like me to open audio or chat features?
Why don't you open the audio, because the chat doesn't seem to be working for me.
Okay,
so,
here we go.
Okay. Yeah.
Let's see. Unmute all.
Okay. I don't hear anybody. Any questions? You guys have been so quiet.
They're popping up one by one here.
Okay. Some
I
of
do
them may not
have
know that
some
you have a
audio.
microphone. Well, that's fine.
I've got a question, Matt.
Yes.
From bad soil to good soil, what's the average length of time if you start doing the correct inputs?
You know, it does vary a lot depending on the conditions that you start with, but we usually see 2 to 3 years where things really start turning around. And you know, you'll get results in the first year of making the changes, but to get it to a point where it's like where you've implemented all of the strategies and everything and get it pointed in the right direction, it usually takes a few years. Yeah.